welcome back to AI Path. MCP and Agent Protocols, Part 4. Today we tackle the trickiest part of building an MCP server, authentication and authorization. Who is the agent, what are they allowed to do, and how do we make sure their tokens never leak? OAuth flows in plain English. Let's get into it. First, two words people mix up constantly: authentication and authorization. Authentication, sometimes called authN, answers the question, who are you? Like showing your ID at the airport. Authorization, authZ, answers a different question, what are you allowed to do? Like which gate your boarding pass gets you into. An MCP server has to do both. First it figures out which user the request is from, then it figures out whether that user is allowed to call this specific tool. If you only do one, you have a security hole. Both are mandatory. OAuth is the standard way to do this for remote MCP servers. It sounds scary, but the idea is simple. 5 steps. Step 1, the user clicks connect in their agent. Step 2, the agent opens a browser window to the auth provider, like Google or GitHub. Step 3, the user signs in, and the provider asks them, do you want to give this agent permission to read your stuff? They click yes. Step 4, the provider sends back a special code. The agent trades that code for a real access token. Step 5, the agent uses the token in every MCP call. The token has a limited lifetime and limited scopes. Notice what didn't happen. The agent never saw the user's password. Never had to store it. Never could have leaked it. That's the whole point of OAuth. And there's a modern twist called PKCE that makes this even safer for desktop apps. Always use it. Now scopes. A scope is a label that says what the token can do. Like read your email or send messages in one channel. Most servers get scopes wrong by asking for too much. Don't ask for full account access when you only need read-only on one folder. Users will deny you and your install rate will tank. The rule is least privilege. Ask for the minimum your tools actually need. Better still, define your scopes per tool, not per server. If only one of your tools sends emails, only that one tool should require the email scope. All the read-only tools should work with a smaller, safer scope. And on the agent side, when you call a tool, use the token with the minimum scopes for that exact call. Don't reuse the powerful one everywhere. 5 token hygiene rules. Memorize these. They're what separates a secure MCP server from a Twitter incident. Number 1, never log tokens. Not in regular logs, not in debug output, not in error messages. Tokens leak through logs more than any other channel. Number 2, store tokens encrypted at rest. If your database gets dumped, the attacker should get useless ciphertext, not live keys. Number 3, refresh tokens before they expire, not after. If you wait until the request fails, you've already broken the user's flow. Number 4, revoke on logout. When the user disconnects the agent, actually call the auth provider's revoke endpoint. Don't just delete locally. Number 5, HTTPS only. No exceptions, even in development. Plain HTTP plus tokens equals a stolen identity. These 5 rules cover 90% of token security incidents. Quick recap. authN is who you are, authZ is what you can do. An MCP server needs both. OAuth is the standard, 5-step flow, agent never sees the password, use PKCE for desktop apps. Scope per tool, not per server. Always least privilege. And remember the 5 token hygiene rules. They're what stand between you and an embarrassing security postmortem. Next time we close out the series with the future of remote MCP, discovery, lifecycle, and the new agent-to-agent protocols. If this helped, subscribe and I'll see you in part 5, the finale.